Hey you guys, at this point I want to show you how to do electron configuration when you have to figure out those in the F block or the inner transition metal section, which is this section right here on the periodic table. Now keep in mind that F orbitals can hold up to 14 electrons in the 7 lobes. So it's not coincidental that if you count the columns across the F block that you're going to find there's 14 of them. Now where do they fit amongst the periodic table? So if you look on your periodic table, you're going to have your 6s. And then what you're going to have here is lanthanum is going to be right here. And this is the number that you get before you come down here to your F block. So if you follow your atomic numbers, you're going to hit lanthanum, and then you're going to come down here, come across, and then your numbers will come back up here right next to hafnium. When you're in the 7s, you start here with actinium, and you come down here across your 5F, and you come back and you'll hit the RF right here, element RF. So what you'll see here is, so basically you've got to like stop kind of what you're doing right here when you get to that part of your periodic table, and then you head down and you grab your F orbitals. Another thing you should notice too, and it's because of the off-ball process, but you have your F orbital is a 4F here. And this 4F would fit in the 6s, 5d, 4F in this area right here. And so notice you're thinking, well, it's 4F. Why do I have to go and like subtract 2 essentially? And it's because of the off-ball principle. And I'll show you that again here in just a second. And the 5F portion here, so this 5F goes 7s, 6d, and 5F. So let me show you some examples of how this works, and hopefully you'll get a better idea of pulling this together. So I want to go back to the off-ball process because that's where people get confused and they're like, but I'm in row 6, why do I want to go to F? So what I want you to see here is with the off-ball process, remember we fill the lower energy levels first. So we fill that 6s, and then we come back and we fill the 4F next. And so it's 4F because the F is in energy level 4, and then we fill our 5D, our 6P, and then we fill our 7S, and then we go to fill our 5F. And again, this has to go back to the off-ball principle because we're filling in those energy levels of lower energy first up to the highest energy. Just like if we were building a building, we have to build the ground floors first. So let's do some examples here. If I had to write the electron configuration of mercury. Now, mercury, I realize on this periodic table, there's no actual letters on here, but I just wanted to keep these spaces on here of like the 1s, the 2s, the p's, and the d's, and the f's, just so you can kind of like see the whole transition and the whole idea. So if I started from the get-go, I would come up here and start with my 1s2, and I would go and address my 2s2 and keep going across, and I have 2p6 because I fill it all up, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Now here's the tricky part with the f's because the f's really are fitting in here. So there's two options you could do. You could do 5d1 and literally put 5d1 and come down here and grab your 4f14 and then come back, and you're going all the way into D, but then you'd have to do 5d9 because you've already addressed the 5d1. Or you could realize that you're going to go all the way to 5d10 to get to mercury. So you could say 5d10, but you can't forget this 4f14. So my final answer would be what I have here. So I want you to see 6s2, 4f14, and I went all the way through the 5s, 5d10. And the reason why I put the 4f first is because in the off-ball principle, the 4f comes before the 5d in level energies. Take a look at this example here. If I were to do mercury, but I were to do the same thing, but a core notation or a noble gas notation. So what you do, since this is in the 5d orbital and energy level 6, then I would go find the actual noble gas that was prior to. And that noble gas is going to be xenon up here. So I would put xenon, and then I could write 6s2, 4f14, 5d10. So I could write my electron configuration with the shorthand or the core notation as seen here and at the bottom. Notice again, when you do this, when you use your noble gas notation, you have to put what we call hard brackets there, and that just indicates like, hey, you understand all of the electron configuration up to xenon, so let's just keep going with that. What if we had to write the electron configuration for tungsten? And tungsten is within the d orbital itself. So tungsten is going to be right here. So what we could do is, let's do the shorthand notation. So we go to the noble gas that comes before tungsten, and that noble gas is going to be xenon again. Okay, so we go xenon, 6s2, and we have to remember this 4f14, and then 5d, 1, 2, 3, 4, 5d4. Again, you could, if you see it differently, you could go 6s2, and you could address this one, because if you look at atomic numbers, you could go 5d1, 4f14, and come back up here to do 5d3. Again, it's up to you on that. I personally choose to put all my D's together because that way I won't miscount and accidentally count a D too many times. So notice how I write it here at the bottom. Okay. What if I had to do something where I'm staying within the F level? Okay, so I'm finding the electron configuration of uranium. Now this one's just a little trickier because this is where this would fit in row 7 here. So I'm going to first find my, this is going to be radon, so my noble gas notation. So I'm going to put radon, 7s2, but here's the tricky part. I have to address this as 5d1. Or my numbers will not count up and add up to be proper if I go to add my superscripts to equal my number of electrons. So I have, I'm sorry, not even 5d1, 6d1, 6d1, and then I come down here and I say 5f, 1, 2, 3, 5f3. So I actually did this one incorrectly. So it should be 7s2, 6d1, and 5f3. And I apologize greatly because it should not be 5f14. Okay, so I should have it as the radon. 7s2, 6d1, 5f3. Because I'm only going to uranium. The reason why I don't fill the whole 5 is because I'm stopping in the 5F. So I only address one 6D, and then I come back up here and start to finish my 6Ds if I were to finish my full 5F row. Okay, here's some examples just to I want you to take a look at and follow on the way we've been doing electron configuration and see if these can also help you better understand where to find and how to do some F orbitals. So give it a try, add those in there. Remember, ultimately, if you add your superscripts, that should equal the total number of electrons you have in that atom. And if for some reason, like with xenon, when you go back to add them, xenon, neutral xenon has, let's see, 56 electrons. So 56, and then you add your 2, your 14, and your 3, and you'll get the number of electrons of tantalum. All right, good luck, you guys.